This is section 15.4, and we talk about the fundamental theorem of calculus. And because this is 1325, we're not going to go near as deeply into it as we would in regular calculus. But the gist of it is now we're going to be taking the integral with specific limits. And so we're saying the integral from a to b of f of x dx is f of b minus f of a. So if you were doing that by hand, you would take the integral, we'd pull the 4 through, and then we would have t to the 4th over 4 plus c. Well, those cancel out, and you end up with t to the 4th plus c. That was an indefinite integral. We did not have specific limits of integration. That's just in general. So if we did it by hand, we would do the same thing, get the integral, but we don't have a plus c, and then we would evaluate it at 1 and 2. Here's the upper limit. So we do 2 to the 4th minus 1 to the 4th, that equals 15. So your answer for the definite integral will be a value. Now, there is a way to do definite integrals on the calculator, and we can do those. We'll do some of those by hand, and we'll do some with the calculator. So let's look at our problem set. We start out here, the integral from 1 to 5 of 3 dx. Well, the integral of 3 dx is 3x, and we're going to evaluate it 5 and 1, so 3 times 5 minus 3 times 1, your answer would be 12. That one's pretty simple. Number 2, also not too bad. The integral from 2 to 4 of 2x plus 7 dx. When we integrate this, we get 2x squared over 2 plus 7x. Those 2's cancel out, so we have x squared plus 7x evaluated from 2 to 4. So we start at the top. 4 squared plus 7 times 4 minus, and I would say put that in brackets because you're going to subtract all of this, and it's 2 squared plus 7 times 2. So 16 plus 28 minus 4 plus 14. That is ultimately 44 minus 18, and that gives us 26. So nothing new on the integration. We're just evaluating at our limits. All right, let's look at number 3. Integral from 0 to 1, 7x squared minus 8x plus 3 dx. 7x cubed over 3 minus 8x squared over 2. Remember, that goes up by 1, and then you divide by that number. Plus, constant always becomes the x. So we've got this. We're going to evaluate that from 0 to 1. And we know that all this is multiplication, so when we plug in the 0, it's gone. So that's not going to be any problem. We're plugging in 1 here, and here, and here. So we have 7/3 minus 4 plus 3. And so that's 7/3 minus 3/3. And because this together is a minus 1. So that's minus 3/3, and we end up with 4/3. So that's those 3. Now, I'm starting to show you how to do these on the calculator. You can do these, any of the definite ones you can do with the calculator. So, integral of 4 over 4x minus 5 squared dx. So, we're going to do this completely in the calculator, and you would get this number. Let me grab the calculator, and we'll put this here, and I'm going to put it in. I'm going to hit math, and we want number 9. That's an integral, so we'll hit 9. When we do, we get this nice little icon, so we're going to put 4 there, and hit your right arrow, and we'll put a 5 there. We'll come here, and we need to put this function here. So I think if I do second and the y equals, nope, not that. Let me go back, second quit out of that. What was it? alpha and y equals. And if I choose number 1, that's going to give me a fraction. I did it in the wrong place. Let me just pause and fix. Okay, so I fixed it and I'm in this square. So if I do alpha and the y equals, it allows me to just say, go ahead and give me a fraction. So I'm going to hit enter. And now it's just easier. I can put 4 on the top, and I go down here, and I have parentheses 4x minus 5, close parentheses, squared. And then I hop out here, and I put my x. So you'll always put x on these when we're doing these on the calculator. You put your function in here, just as it is right here, and you put your limits here. And so we'll hit enter, and let's see if that's what I had. So 0.0242, and I think it said to round to 4 places. So that's how we're going to do. Now, that's if you had the newer operating system. If you have an older one, like a TI-83, you can still do it. It's Math 9, and it would put int on the screen with a parenthesis. You can put this as your function. So you always put the function, comma, x, comma, lower limit, upper limit. So you can still do it that way even if you don't have the newer operating system. All right, number 5, definitely one that's easier to do on the calculator. And I put the screenshot here. So integral from 0 to 8, I put the function here. And you can, when you put x and you hit your caret key, you can put 1 divided by 3. And then inside, you have x to the 4/3 plus 9 come out, and you've got dx, and you should get 245. So I think that those two are definitely easier doing the calculator. You can do any of them that way, but I wanted to show you how to do them by hand, and then for the more complex ones, definitely use your calculator. All right, number 6. So this one just says the total area of the shaded region is. And we learn that total area has to do with integration. And so if we look here, we've actually got 2 regions. We've got here to here, and then this little region here. So we've got from 0 to 12 and from 12 to 13. So what you need to do is write your integrals. So it told me that this is y equals 144 minus x squared. So for this region, it is from 0 to 12 of 144 minus x squared dx. And then we're subtracting this y equals 0, so we don't really have to put that in there. But this piece is below the x-axis, and the thing that's on top is the x-axis, sorry, the y equals 0. So in this one, we have to do the integral from 12 to 13 of 0 minus the parabola. And so I would write it like that. And go ahead and write these out. This one is the same as minus 0. I just didn't write it there. So whatever's on top goes first. Whatever's on the bottom is what you subtract. So for the second little piece, it was y equals 0 on top. There you go. Minus the parabola. Once you've gotten those written, you can go do them with Math 9. So I did this one. That was 1152. I did this one. It was 12.33 repeating. And then I added those two. Now you could do all of that in one thing if you feel comfortable doing that. And then I just turned it into a fraction because it does want a fraction for your answer. And that was 3493 over 3. So that's how we'll do the area of the shaded region. When we go to number 7, I believe, and I think that's it, we just have 7 questions. So use the definite integral to find the area between the x-axis and f of x over the given interval. So they didn't give you a picture. We have to graph that on our own. So I did do that. I got this blue graph here. It was 5e to the x minus 5. So you just put that in your y equals, and you've got this picture. And then because it's between -5 and 2, so here's somewhere close to -5. 1, 2, 3, 4, 5. It should be on that little dash. I was just sketching. And then here is 2. So we can see we have a shaded region here. We have a shaded region here. So again, we're going to write our two integrals from -5 to 0. And if it weren't apparent where they cross, you could put in y equals 0 if you wanted to find, but you can pretty much see it does cross at x equals 0. -5 to 0, what's on top here is y equals 0. So we got 0 minus parentheses 5e to the x minus 5, parentheses dx, plus now from 0 to 2, our function is on top and the zero's on the bottom. So I wrote it like that. So this is showing the Math 9 icon. This is from -5 to 0, and then over here you had 0 minus. I didn't put the 0 in there, so I had the little baby negative outside this because we know it's all going to be negative. And then put that in parentheses, dx, and you get this 20 point, and it's got a decimal. From 0 to 2, we have that minus 0. I didn't have to put that in there, and I got this number. I'm adding both of those numbers, and we got 41.97897022. The question, I believe, says round to 3 places, so 41.97, that will round up to a 9. So those aren't too difficult when you're using the Math 9. You do have to graph this one. Go to y equals and put that in. You could put y2 to be 0 just to double check where they intersect, but this one we can see pretty well. Write your two integrals. Do those on Math 9 and add them together. So that's what we're going to do on this. You can do these for practice. You could do these by hand, the first few, and then do the others with Math 9. I think that will do it for 15.4.